away from here is a bit colder and higher, and my AOI is highlighted in the green. I don't know if you can see the green polygon here. The area is 0.70 kilometers square. It's located in the rural district of El Prado in Facatativá. It is part of the cloud forest ecosystem, as I told you before. The average temperature is 13 grades centigrades. The precipitation is almost 2,500 millimeters per year, and the relative humidity is very high. Of course, cloud forest is between 90% to 93%. The AOE was really affected years before by land use change. This produced vegetation loss, erosion processes, and even less water in the two rural aqueducts that are near to my AOI. Due to these problems, it was necessary to carry out this ecological restoration, planting native plants, and follow the Cundinamarca Regional Environmental Entity Guidelines. Now that I gave you the context, I'm going to start with the methodology. I started looking for the best images on those years. That was actually the most challenging part of the project. Since, of course, I was working in a cloud forest, many images were unusable due to the persistent cloud cover. That's why I use Landsat 7, Landsat 8, and Sentinel-2, and to improve time series continuously. And in addition, I selected images just from the dry season. I know that we told you before, but in Colombia we have just dry season and rainy season. The first dry season is from December to March, so I selected those images from that dry season. And of course, I wanted to choose one of them, dry season or rainy season, to have comparable results. Also, I performed cloud masking, and I just was able to select. I work with 4 images per year, just 4, this is less, very less. And I create a median composite of those 4 years per those images from years. I just work with those years. I couldn't work with the old time frame, unfortunately, but yeah. Finally, as you know, the resolution of Sentinel and Landsat is different, so I wanted to harmonize the resolutions. So I resampled all the images to 30 meters to be able to, again, the result has to be comparable. Once I selected all the images, I calculate the biophysical indices. I work with 3 of them, NDVI that you know perfectly, that help me to measure the vegetation vigor and density of vegetation. Also, I work with leaf area index. It uses NDVI for their calculation. And also, I use the land surface water index. See, this is very sensitive on both soil and vegetation water content, and it is very relevant for evaluating hydrological recovery in cloud forest. Then, for each vegetation index, I calculate the annual mean and standard deviation using Google Earth Engine. Then I use Python for statistical analysis. I perform a pixel-wise linear regression that helped me to not only to identify whether the vegetation increased or decreased, but also I was able to identify the rate of change. Once the values were extracted from Google Earth Engine, I use libraries like Pandas, Matplotlib, and SciPy in Python. I use line graph to track temporal evolution and generated spatial trend maps. I also, to ensure that the patterns I observed were statistically reliable, I applied the Mann-Kendall test. I choose this one because it's a non-parametric method, and it is widely used in ecological projects and hydrological projects also. because it doesn't assume normality and it is robust against outliers. So it is very ideal for time series like NDVI. Then I'm going to start with the most excited part of our project, the results. I'm going to start with the NDVI results. You can see in the trend map clear improvement over time. In 29, we can see predominantly yellow tones in comparison with 2024. In 2024, the landscape is mostly covered by values close to 1, which represents dense and healthy vegetation. I have to highlight here, I don't know if you see the difference on that screen, but 2018 looks greener than the other maps, or the other years, and it is because I worked just with 2 images in that area, and one of that image was from the rainy season. I decided to keep it to avoid temporal gaps, but this should be interpreted by caution. To better highlight these temporal changes, as I told you before, I perform a per pixel linear regression, and I generate an NDVI trend map or slope map. This analysis reveals a progressive increase in NDVI cover and vigor across most of the restoration polygon. As you can see, most of the area looks green, but also you can see some red pixels, and it is normal in a restoration, ecological restoration. Some areas in that restoration couldn't be able to keep the plants that we planted in the ecological restoration, and also maybe is related for anthropogenic pressures, soil limitations, or natural ecosystems dynamics. But in general, you can see the general trend shows that there's a very strongly positive increase in the vigor and vegetation into the area. Now, looking at the temporal statistics, the annual NDVI average shows ups and downs. You can see in the green points here in the plot. These fluctuations are expected in cloud forests due to the natural climatic variability that strongly influence the NDVI values. We have to remember that just 4 images were collected from each year, but despite these oscillations, the long-term trend is positive. On average, the NDVI increased 0.0037 per year, which confirms a steady recovery from 2010 to 2024. You can say, but this value is not that high. The literature said that this value from 0.0025 is a good value, so it's representative. Now, I want to talk about the LAI index, the leaf area index. As I told you before, this gives us a measure of biomass and canopy density. In 29, the sites show very low values, but after the restoration started in 2010, we see a rapid increase in 2011, and then we can see a drop in 2013. This is kind of strange. And this is because the ecological restoration have to start with pioneers, plants named pioneers, and I want to show you just 2 of them. For example, chusque is on the top. It's a kind of bamboo, native bamboo here in Colombia, and also we use some shrubs, and they grow very fast and quickly, even in months, and quickly generate a lot of leaf cover. But as I told you before, we can see a drop here in 2013, and it is because, again, the pioneer plants, they have a short life cycle, so their initial boom is not that stable. After that, as trees like alnus and arboloco, I brought just 2 of them because we work with 15 kind of trees. The LAI steadily increased again, as we can see in the map. By 2020 to 2024, the area shows dense and homogeneous canopy cover, which indicates that the ecosystem is moving toward the more mature and stable stage. Now, I want to talk about the land surface water index, which I use as a proxy for hydrological recovery. At the beginning of the series, between 2009 to 2011, the values were very close to zero. I don't know if you can see the difference, yes. The colors are more beige than red, which reflects a limited capacity of the soil and vegetation to retain moisture. Over time, especially from 2015 onwards, the index shows a gradual increase and becomes more homogeneous. Here I want to highlight something in the year 2022. I don't know if you can see the difference. Looks more red than the other years. For me it was so strange, but then I realized that in that year, in Colombia was present a La Niña event, or the La Niña phenomenon. This did happen some years in Colombia. It is because the Pacific Ocean gets colder, and it means in Colombia more humidity, more cloud cover, more rainy. So that's why here the LSWI in 2022 is higher than other years. Here also we can see a peak in 2022. Okay, and as I told you before, I applied the Mann-Kendall test to the NDVI time series. As I told you, this is a non-parametric test commonly used in ecologic and hydrological projects to detect whether there is a real trend in the data over time. And the results gave us a Kendall's tau of 0.60, which indicates a moderately to strong positive trend. And more importantly, the p-value was 0.046, which is below the 0.05. This means the probability that this trend is just random noise is less than 5%. In other words, to be more simple, we can say with statistical confidence that the vegetation recovery we see is real and consistent and is not just fluctuations or noises. Small, I don't know why this is too small, but okay. Of course, I faced some challenges. First one was the high cloudiness. I just be able to work with 4 images per year. I wanted to work with many of them, 100, but it wasn't possible. Of course, I was dependent of optical sensors, and the variability, of course, the NDVI is very sensible of those variabilities in climate and the variability of the image itself. For the next steps, I want to follow this project later. I want to integrate SAR sensors, and also I want to include field monitoring. I want to say something here. With my father, we tried 4 months ago, 3 months ago, to go to the area to take pictures and to bring them here, but the path was closed. One man was there, just blocked the path, and they told us, no, you cannot, because this property is private. It doesn't make sense because that property is from the municipality. So yeah, we didn't want to fight with that guy, so we went directly to the municipality. We have to send a letter. They told us that yeah, we have to send policemen and blah blah blah. But yeah, so I couldn't take the pictures. But this is a good benefit of the remote sensing. Of course, I want to incorporate climate data, precipitation, temperature, humidity, and also I would like to include the community. So I would like to ask them if they perceive changes in the area, like maybe they can hear more birds, or they can perceive more water in the aqueducts nearby, and so on. I would like to include that data. As a conclusion, the restoration shows a sustained vegetation recovery. In terms of structure, we can see higher biomass and vegetation cover, that as we saw in the NDVI and NLI at the beginning. And yeah, thank you so much. Those are the references. Gracias, thank you.
Thank you, Monica, for your nice presentation about how the biophysical parameters necessary for assessing the cloud forest restorations. And now the point is there any question from audience?
Yes. Yep. Thank you. Thanks a lot for your wonderful presentation. I have one question regarding the harmonization between Sentinel and Landsat, because you talk about the spatial resolution harmonization, but did you face any challenge in the spectral bands while composing the index? For example, because of course when you create the NDVI index or the other index, you take in the same bands, the red or the infrared from each of the products, but I guess there are some small misalignments, yeah, in the part of the spectrum you take. Do you find any, I don't know, misalignment or problem or gap, abrupt change in the time series, and whether, and also did you consider to also apply any type of harmonization also in the spectrally? Yeah.
Okay, yes. First, I was reading that was possible to resample the images from 30 to 10. I read this was very complicated, so I decided, and I used just 2 years with Sentinel-2. I took just 30 meters. I resampled to 30 meters all the bands, also all the bands that I used, because even if I resampled them, I found some differences. Yes. I should told which years I used with Sentinel-2. I don't remember right now, but yeah.
Okay, what about the phenology of plants in that particular area? Have you been encountered that? Is there all, what do you say, evergreen plants or deciduous kind of plants?
Here we don't have, the trees here always are green, always. And we planted in that area native plants that are native in that specific area, because it's not the same cloud forest than normal forest. So we made first a characterization of that plants, to select the best ones.
It's okay.
Thank you so much for your presentation, and actually I have a question really close to yours. I'm not that into this type of forest, which is completely non-existent in my country, but I think in terms of phenology, plants here, the growing rate is really low. So that's why actually if you see the NDVI slope trend, is not that high, right? Even she took several years. So my question is, do you think if you took more years, maybe with one satellite, you will have a better trend on your results?
First, I cannot take just one satellite because 2 reasons. First, as I told you before, I wanted to work. It was easier to work with just one satellite because I don't have to worry about the reflection and resampling and so on. But it was impossible to work with just one satellite images. Of course, if I work with just one, the trend will be more comparable. But I don't know, because I couldn't work with just one satellite, so I couldn't say if the trend would be better or not. Yeah, but I would like to make this analysis from the next years to see the recovery of the area and so on.
Thank you, Monica. We'll move to next presenter. It is good that your father helped out for your data collection. Thank you.
Thank you.
We are the last presenter as per the AGSE technical concern. He is Mr. Suraj, and he is having more than 12 years of experience in the field of environmental and ecology. Now he is associated with Digital University of Kerala, and he has completed his BSc Botany from 2007, Government Arts and Science College, and 2009 he has completed MSc Environmental Biotechnology and from Cochin University of Technology, and MPhil from Cochin University Ecological Informatics, and he has completed PhD in 2010 in the field of ecological informatics, and his specialization and interest in ecology and environmental sustainability. Now the floor is yours, Suraj. You can start. Thank you.
Good afternoon all, and I think this is the last presentation of AGSE 2025. Okay, so today I will be presenting is something like a kind of synthesis work actually that we are doing now. So I will be presenting some result that we obtained as of now. It's a geospatial approaches to plant invasion risk under climate change, as in this of recent advances from 2020 to 2025. Okay. So before moving to, I will be giving a short, brief introduction about the biological invasion and its impact and all these things. And this is one of the famous quote from Professor Charles Shelton. Actually, he did some seminal work on the biological invasion. So this quote emphasized the importance of taking care about our environment, especially in eradicating the biological invasion. So biological invasion, I think it's a very familiar term. I think all of you are aware of. I think in your countries also you may experience the various issues of invasion. So invasion is basically considered as a creeping disaster, wherein a species establishes itself in a region that has not been previously present, and it impacts or extensively causes various impact on the ecosystem, and it affects the ecological equilibrium also. So according to the Millennium Ecosystem Assessment in 2005, it is considered as the second most threat to the global threat after the habitat fragmentation. So there are multi-dimensional impacts are there. It can cause environmental impact, it can cause economic impact, and various social and cultural impact. And regarding the economic impact, there are various reports and various studies are there. It causes billions of dollars of loss in, especially there are some studies from USA, and many studies are there around the world. It causes a huge economic impact especially to the agriculture production and all these things. Okay. So basically, I just give you an idea about what is the process of invasion. That will be easy for you to understand what I'm explaining later. So basically, when an invasive species, there will be a transport. Okay. In most of the case, if you look at the biogeography of any plant and species, there are a lot of barriers. Basically, one of the things is geographical barriers are there. Large oceans, mountains, all these things basically restrict the transport or the movement of any species. But in this global era, due to the various trade and there are a lot of human activities are happening. So nowadays, it is not a big task for a species to move from its place to another place. Through the human-mediated pathways, there are a lot of invasive species are distributed all over the world. So it get transported, then it get introduced in a place, and it starts slowly establishing in that range. After the establishment, it slowly spread its range. Okay. So basically, the establishment, we say when a plant established in an area, after that it can it can produce or it can attain a viable population that is basically regarded as an establishment. And after that, it slowly spread into newer regions. So there are many studies. One example from India, basically, there is a species called Mycenia micrantha that is basically belong to Central and South America. It was introduced in India during the Second World War, basically to camouflage some airfield set up in the northeastern region part of India to defend the invasion of Japanese allies. But that species has become one of the worst invasive species in India. If you travel everywhere in India, you can see that species, especially some other species like Lendana camera. It was introduced in Calcutta Botanical Garden just as an ornamental plant during the British period. But if you travel each and every pocket of India, you can see that species. Such a manner, it is extensively spread to various regions, especially in our forest region. It causes a lot of issues in the forest. Okay, these are the different determinants of a invasive species. Basically, for every species, there are it's called traits. We all have various traits. Okay, so in the case of invasive species, something is in biologically we call it as phenotypic plasticity. Okay, for example, when you travel to, for example, if you travel to India, especially from Europe or South America, you feel, especially in summer season, and you cannot, I think, it's very difficult to survive kind of thing. Okay, but these kind of species, they have plasticity, they will be easily adapted to the region they were introduced. So that is a great advantage for them. So what will happen, they have various kind of traits and some system, especially the properties ecosystem, the recipient ecosystem. If there are is there any issues or is there a disturbance to a system, these species can easily invade to that region and it can establish a good population. So the resource availability in the invader region, different anthropogenic activities happening or disturbance to the system, and biotic combination, biotic presence, species combination of or composition of that area, and biotic resistance. These are some ecological terms that generally we call as biotic interactions. Okay, these all depends the success of an invasive species. So there are multi-dimensional aspects are there. That is basically when we model the distribution, we include all these different multi-dimensional aspects. Ecological aspects are there, biological aspect, like as I told, the species traits, phenotypic plasticity, different stages in invasion, how it interact with the host system, and environmental and geospatial things are like suitability, habitat, climate, topography, then land cover, climate change impact, and connectivity. These are the various environmental geospatial dimensions, and socio-economic and anthropogenic things are there. I explained the story of Lendana camera. It is just introduced as an ornamental plant, but it causes a lot of issues nowadays. Then policy and governance, because many countries have very strict what you call the quarantine rules. You cannot simply introduce any species to that particular countries. But some countries are very liberal in quarantine measures, especially for example India. We have a lot of exotic plants, exotic fruits. People are simply bringing a lot of exotic plants to a region. Particularly there are some quarantine measures are there, but I think it is a little bit liberal. That is why many species are getting introduced to various plants. I think it is happening in various other countries as well. Then cultural and perceptual dimensions are also there. Before moving to my core discussion, I will just give you an idea about what is an ecological niche. That is the basis for basically if you model the spread of invasive species, the basic idea is called ecological niche. So I think all of you are familiar with this word. Sometimes this niche, the word niche is, we use this word in synonymous with what is habitat, but there are some difference. Habitat basically means the place where an organism lives, but when it comes to the ecological niche, that includes the interaction also. The technical term is the functional role of an organism in an ecosystem. That is the niche. But in that perspective, we need to consider about various factors that controls that particular species or that facilitate that particular species. So it is regarded as n-dimensional hypervolume. There was a seminal work by Hutchison in 1957. It's called n-dimensional hypervolume. This it's a multidimensional. Just imagine about a species. If that particular species to be occur in a place, something like n-dimensional hyperspace. This is a multi-dimensional space. Each dimension here indicates various environmental or any or biophysical variables that decides that particular species. That is why it is regarded as the n-dimensional hypervolume. So when you look at any species, there is two type of niches are there. One is called the fundamental niche and the other one is the realized niche. Okay, fundamental niche is something like an idealized case. For example, for our survival, we need some kind of what you call the different variables. Like, for example, if you in terms of temperature, pH, or whatever it is. Okay, so if you have that particular, if you are provided with that particular condition, you can survive in that place. Okay, but that is not the case. But if you are really introduced or introduced to that particular place, there are a lot of interactions are there. Okay, especially in the case when you introduce some animals. All the biophysical conditions are okay, but there will be some biotic resistance, there will be predation, there will be some other kind of what you call the interactions are there. That really decides the actual niche of that. That is called the realized niche. Okay. So basically, invasion risk studies integrate as I told you, it's a multidimensional thing. So in modeling, what we are doing is which species are likely to invade, what are the most likely to establish and spread, and how do human and ecological drivers interact, when and under what scenarios will risk intensify, or what actions are most effective to mitigate these risks. These are the various questions being asked in this particular geospatial model. So geospatial approach is very, very essential, especially when you study some what you call plant invasion risk assessment. So it helps you to mapping the current risk, predicting the future spread, or you can integrate in various drivers, and it will help you to the what you call take decisions. It supports the decision making process, and it also helps you to monitor and early detection of what you call the early detection is one of the fruitful solution to eradicate this thing. So if you model something and if you are saying that if your area is prone to invasion, so you can take some proactive measures to control the species invasion. So the context of the presentation is I just review some of the geospatial approaches used to understand the plant invasion risk under changing climate change scenarios. So this is just a bibliometric analysis. I searched for these are the keywords I used. I searched in the database like Web of Science, Scopus, and Google Scholar, and I got around 660 papers that deals with that suits with the current theme. That means the plant risk assessment using geospatial approaches in the 2022-2025 years. But I set some exclusion and inclusion criteria. Basically, in this particular work, I am focusing on plant invasion, especially in the terrestrial ecosystem. So I just excluded the animal invasion as well as the invasion happening in the aquatic ecosystem. So finally, I took around 80 papers, and these are the you can see the graph. The publication happens during the last 5 years, and you can see some surge in the publication in 2024 and even 2025 also. There are a lot of publications are happening in this sector. So these are journals. The most number of papers are published. So getting questions for this particular synthesis is one is what geospatial models are frequently used in these studies, and which climate change scenarios are applied for these studies. What are the key data sources, what recent approaches are emerging, and what are the current trends in modeling, and what spatial predictors are most important for these studies, how does farming influence invasion risk, and what are the key gaps and some future recommendations. So these are the most, I think, you can recognize some of the plants. The first plant is called the lantana camera, that is a very notorious, and one of the worst. Actually, there are a database that have the worst invasive species of the world. There are 100 species are there. I think it tops within the first 10 category. So I think you can identify some species. So these are the species studied in this particular research. So coming to the species distribution modeling, we do the distribution modeling to understand the potential distribution of that particular species using the existing the occurrence data sets. So we have occurrence data sets, and we have some data regarding its habitat requirements, and we use some, basically there are some conventional traditional models are like max and domain, bioclaim, these are the conventional models. So using this environmental data, it creates something like a probability map, so that you get, commonly it ranges from 0 to 1, so 1 indicates high risk areas and 0 means non-suitable area. You will get some map something like this. This is the way in which we are doing it in conventional mode. But in the last 5 years, there are a lot of since the emergence of AI and machine learning techniques, actually people are integrating these conventional models with machine learning things, and they are getting some good results. So this is the frequency of model used. You can see anyway the maximum entropy model is tops the still people are using this model. Then you can see random forest, ensemble models, generalized boosted models, a lot of models you can see here. Okay, and here you can see the category of models: machine learning based random forest, boosted regression trees, or ANN classification trees, and regression based thing GLM and GAM also. Then specialized in a hybrid thing. I told you people are integrating different things, they are coupling different kind of models to get the better prediction. So regarding the data, most commonly used climate change scenarios are RCP pathways. You can see here RCP 2.6, 4.5 and 8.5, and also people are using socioeconomic pathways. Since I told you invasion is basically a human mediated activity, so the socioeconomic activities plays a major role, because socioeconomic activity also have the impact on the climate, greenhouse gas emission, and all these things, and this invasion is very sensitive to the climate change and all. So that is why most of the papers are using RCP pathways and SSPs. Okay, then key data, these are the key data sources used for this model: World Climate Database and CHELSA climate models, AfriClim basically for the African regions, ERA climate reanalysis data, PaleoClim, and global climate models. You can see here, these are actually there are plenty of models are there. I just highlight some of the mostly used climate models. Then climate change scenarios, I told you RCPs and SSP pathways. These are the commonly used scenarios. For land use, land cover thing, these are the data sets used. In here, International Geosphere Biosphere Program data, Earth Environment data sets, Copernicus, you can just read it here. And for the topographic data, I told you it's a multi-dimensional thing, so people are bringing lot of whatever the socio-physical or biophysical data sets can be plug in these biophysical data sets into the modeling. So human activity is very important. So these are the human data set regarding human activity used. And for the remote sensing is an important part, especially since these are all connected spatial things. Sentinel, Landsat and MODIS data are being used frequently for this modeling. And recent approaches, I told you in the conventional way, people are using Maxent or these models, but nowadays people are using hybrid models, like hybrid species modeling, because they are comparing, for example, the agent-based modeling frameworks are there. They are comparing Maxent with agent-based modeling. I give you a reference here in cellular automata models and integration of biomes as a predictors. They are adding more predictors to get a better results. Okay. Then hierarchical modeling and refined risk mapping. I will show you some of the results. And regarding the socioeconomic, that is very, very important. Advanced socioeconomic and urbanization indicators are being used regularly in this kind of modeling. And integration of multi-source remote sensing data with advanced analytics and multi-GCM averaging and advanced climate scenarios. Instead of using a single model, people are using different models and they are averaging the results, and these results is used as input for some other hybrid models. These are some framework for a modeling framework to biology invasion for invasion grand flora in North America. Here they use the Maxent along with the agent-based modeling. This is one of they integrate the multi-source remote sensing data with advanced analytics. Here you can see they use satellite data and DEM for the digital elevation model for the topographic things, then bioclimatic data. They also use the emission scenarios and also collect the field data from the field. And there are some the different hybrid modeling techniques were applied, and it gives more robust results. This is another work, anthropogenic and climate-driven risk multi-species plant invasion sub-Himalayan grassland ecosystem. And they fetch data from the GBAF. There is a repository where you can download many of the species occurrence data. And they use some ensemble modeling techniques for the better prediction. This is also an ensemble model for predict current and future distribution, Alianthus ultimissima in Tunisia. Here is another work. Actually, here you can see different color combination. the suitable areas, and most of the case the output is something like in the predicted climate, in the future climate scenarios, most of the species are expanding their niche. That means the range is expanding, and very rare, for some very rare species, their what you call the suitability is shrinking in some cases. But most of the species are trying to, that is technically is called the niche shift. That is, there is an expansion in the what you call the ecological niche of this invaded area. That means they can invade more and more areas in the future climate scenarios. This is a work basically from India. They use different models like Max and random forest, and they compared the what you call the performance of different models. And when you analyze all this work, I think random forest models are outperformed other models basically. Then current trends, I already explained also. So increased prominence of ensemble modeling. In the earlier times, we have some limitations, so we are using some single models. But nowadays, there is a prominence for the ensemble modeling because people are coupling different models to get more robust predictions. And there is a continued effort for refinement of the Maxent and random forest methods for the robust predictions. And there is it's very evident that there is a shift towards the advanced climate change scenarios. Okay, in the early times, the SSP pathways were not used for this, what you call the predicting the potential niche. But nowadays, most of the works, they are using the emission scenarios for the prediction. Then integration of diverse environmental anthropogenic variables. That is very important because in most of the case, in the earlier model, the problem is you can feel some overfitting kind of thing. Because the predicted niche, it predicted niche, for example, fundamental niche, that you can see a lot of overfitting because lack of integration of different multidimensional data sets. But nowadays there are a lot of data sets are available. So people are integrating various dimensions related to a particular species so that they are getting more robust results. That especially if you are using it for decision purpose, decision making or support system for this kind of activities, this integration is very important because you will get a more realized, more robust results. Okay. So these are the key spatial predictors identified. One is the proximity to road, transportation network, that is very important, and human activity, various disturbances, and human footprint, urbanization or disturbed lands, globalization, trade and travel. I told you about the introduction of various exotic plants in Indian scenarios. Then elevation and topographical factors important, land cover types and habitat and soil properties in some hydrological property. There are various predictors out there. So these are the high emissions. Actually, in most of the work, people do some the modeling for both contrasting cases, something like, for example, low emission cases as well as the high emission cases also. But most of the cases, the high emission scenario like business as usual, like SSP 8.5. So many of the major of studies show that there is a what you call the incremental expansion in the niche of many of the species. And low to moderate emission scenarios like SSP 2.6, it predicts less severe shift, but if you look at the individual species level, there you can see some slight variations. So finally, how warming influence environment, that is one of the important aspects that we are looking into. So the expansion of suitable habitats, this is a global, if you look at the global scale, there is a northward and poleward shift is happening because due to the climate change and all, there is a, for example, the invasion gland flora is predicted to undergo a predominant northward progression. That means poleward, what you call the progression of some species. Then also there is an altitudinal shift, Ageratum adenophora is another species. It's predicted to expand the potential suitable area in the higher elevation areas. Okay. Then new suitable areas are, for example, the Lendana camera. Especially there are some predictions that it can even expand to the Mediterranean region. But right now, I think the Mediterranean region and that Lendana invasion is not there, but in the future scenarios, there is a possibility for its invasion to that region also. Then reduction of cold stress, then enhanced performance and competitiveness. This is something related to the what you call the ecological or biological things, because due to the high temperature and all this, there will be some chance for the what you call the in the trait. Okay, there will be some changes may happen. I told you it's a highly plasticized, it's called phenotype plasticity. They can simply change with respect to that particular environment. That is one of the advantages of this species. So in the what you call the high emission scenarios, there is an increased enhanced competitiveness or evident, then increased vulnerability of ecosystems and impact on life history traits. For example, dispersal mechanism, and there are different things. This is something related to the ecology of that particular species. So what are the key gaps basically in current SDM studies? Are limited inclusion of biotic interaction than other ecology factors. In most of the studies, we are basically concentrated on the bioclimatic variables, but it cannot account some biotic interactions. If we can account those biotic interactions or other ecology factors, you will get a more, what you call the robust predictions. Okay. Most of the time, if you look at the ground, the interaction is very, very important. Okay. Even though the conditions are suitable for a species, if there is any other interactions happening, that may also decides the distribution of species. That is very important. That is a limitation of current studies. And inadequate concern anthropogenic and local scale. Another advantage, another limitation is most of the studies are conducted in the global scale. When you look at the very local scale or regional scale, there will be some inadequacy for what you call modeling purpose, especially the lack of data and all these things. Then model-specific uncertainties and methodology issues are there, because different models give some various kind of what you call the prediction results. That uncertainty is also one of the limitation. That is why people are nowadays using ensemble modeling. So they are getting output from different models and try to average the results. And data availability and quality. That is also very important, because when there is a website called GBAF. It's a participatory platform, so people can enter. For example, if you want to enter a species occurrence in your area to the global, you can voluntarily join, you can add the points. But the problem is when the clustering of data is one of the major problem when you are modeling these things, because you have some data sets, you have more data sets from some points, but less occurrence from some point. That doesn't mean species is not available there, but its lack of reporting is there. So some heterogeneity is there in distribution of species that also affect the modeling. Then future recommendation. Many of the studies give some suggestions, some recommendations for the future studies. Like one thing is to what you call overcome the limitations, integrate broader environmental biotic factors. That will give you a robust prediction that can be useful for the decision making. And enhance modeling methodologies, that is very important, and that is something related to informatics thing, and improve data collection and management, and policy and management recommendation. And these are the references. So I conclude my, and this is a very beautiful quote from Leo Wilson. He is a very famous biologist from Harvard. He is no more, but actually he introduced a word called biophilia. There are beautiful books out there from Leo Wilson, and thank you.
Thank you, Suraj, for your...
Actually, this quote emphasize the interaction. If you see an ant without looking at surroundings, and you didn't, something like that, it emphasizes the importance of interactions between species. Okay, if you want to get a holistic picture of an ecosystem, you should think in the ecological perspective. Then only you get the full realistic picture. Thank you.
Thank you for the detailed presentation. Is there any question? Then thank you. Oh, sorry.
Yeah, just a quick question. Very interesting presentation. You said that in the end that it's very difficult to find local models, because I was thinking, like in my city, it's a very rugged city with a lot of ravines and so on, and like in the ravines there's a lot of natural vegetation, but there's a lot of that we have right now a problem with a species that is taking over and killing everything. So like I don't know if those models are not like, you cannot turn them into local ones, but have you seen any models that you can see these and analyze these like on an urban size, and to see urban vegetation, because also that's like a big problem, I think.
Yeah, that basically when you consider that regional scale, local scale, that is still there is a limitation is there. But otherwise, if you have, for example, if you have some kind of long-term kind of monitoring system, if you have long-term ecological monitoring, this kind of thing, there are some stations are this called long-term ecological monitoring station. They are continuously recording various biophysical parameters of particular regions. But unfortunately, most of the things, for example, generally people are using world climate data sets for modeling, but the resolution is something like I think is 1 kilometer. 1 grid means 1 kilometer. But that cannot be used in the regional case. But there are some isolated attempts, because if you have some what you call that monitoring kind of facilities, or if you have good data infrastructure in your local area, you can simply integrate this thing. But many of these studies are, the scale of these studies are, many of studies are in global scale or some country scale. That's resolution is the, spatial resolution is really a constraint for this kind of analysis. Thank you.
Thank you very much. It's time for lunch. And after the lunch, we will be meeting for a workshop by Hamidras Astavas about QGIS.
One short moment, an announcement, please. Everyone will have lunch, me too, but I would try to be quick, and then I